To the next lecture of the subject of the electric circuits. In last lecture we have discussed the Norton's theorem, the statement for the Norton's theorem, then what is the applications of the Norton's theorem, and also discuss the stepwise procedure that how to calculate or how to analyze a given circuit using Norton's theorem. And we have learned that the Thevenin's theorem and Norton's theorem had some equivalence, and that equivalence we have calculated in the concept of equivalence between Thevenin's and Norton's theorem. And using this transformation we can also obtain the Norton's equivalent circuit from Thevenin's equivalent circuit. That means if we have calculated the analysis using Thevenin's theorem, then also it is possible for us to perform Norton's analysis by using the formula of VSC is equals to ISC into RTH. So what is VSC, what is ISC, what is RTH? We have concept, all this concept has been discussed in the last lecture. So in today's lecture we are going to discuss the next theorem, that is the maximum power transfer theorem. We are going to discuss the maximum power transfer theorem. So before discussing what is maximum power transfer theorem, we will discuss first the concept of what is power. To understand this theorem, first of all we have to understand the concept of power, what is meant by power. So we will discuss some basics regarding the power which we have discussed during our school days. So this is the concept of power. We are discussing the simple language, simple manner मध्ये आपण power discuss करतोय. So power is nothing but time rate of doing work. Time rate of doing work. That is called power. Means how much time is required, or we will say work done per second is called as power. Work done per second is called as power. This is the formula for work upon time. Power is equals to work upon time. But that is a concept in science. This concept is according to science, according to physics. Physics नुसार concept है work upon time. But we are interested to define the power in the electrical quantities like voltage and current. Voltage, current and resistance. We are interested to define the power in the terms of electrical quantities like voltage, current and resistance. So, to define the power in the electrical quantities, we can write down the definition of power as product of voltage and current. Product of voltage and current. In first chapter we have learned the concept of apparent power, active power and reactive power. So in that these three powers are classified on the basis of sinusoidal waveform. सायनोसोडल वेव्हफॉर्म जर यूज होत असतील तर त्या ठिकाणी पॉवर अशा प्रकारे तीन आपल्याला मिळतात की ऍक्टिव्ह, रिएक्टिव्ह आणि ऍपरंट पॉवर एसी सप्लाय मध्ये, सायनोसोडल एसी सप्लाय. बट इफ यू डिस्कस द डेफिनेशन ऑफ अ पॉवर when a DC power supply is given to you, then it is just simple that product of voltage and current is called as power. DC मध्ये मात्र फक्त व्होल्टेज आणि करंटचा प्रोडक्ट म्हणजे पॉवर आहे, एवढीच डेफिनेशन आपण DC पॉवर सप्लाय मध्ये डिफाइन करतो. ओके, अँड दिस पॉवर इज written in formula as V into I. But we know that according to Ohm's law, I is equals to VR. This is rearranged formula. The original formula is V is equals to IR. Original formula is V is equals to IR. So rearranging this formula in this format, I is equals to V by R, and replacing the value of I by V by R, we will get the second formula for power as V square by R. V square by R. That means this is your first equation, V into I. This is your second equation, V square by R. Now substitute Ohm's law. This V is equals to IR. Again in equation number 1. Again in equation number 1. So V is equals to IR. So IR divided by R in this formula. Sorry. See how this formula is derived. Replace V is equals to IR. So instead of V, I am putting here IR, and V square is there. V square है म्हणून हा I square झाला, IR square झाला, IR square divided by R, divided by R. So R get cancelled. Your formula for power is I square R, I square R. Or if you put this value in equation number 1, replace V by IR. So IR into R. IR into I, not IR into R, IR into I. So I into I square into R. Again this equation number 3 will be derived here. Okay, so these are the equations for power. Power या प्रकारे calculate करता येऊ शकते. But in DC power supply मध्ये अशा प्रकारे power calculate करता येते. In DC power supply, the concept of power factor is not applicable. DC मध्ये power factor चा concept apply होत नाही, कारण DC मध्ये करंट आणि व्होल्टेज हे ऑलरेडी फेज मध्ये असतात. असं आपण कन्सिडर किंवा फेज डिफरन्स 0 आहे त्यांच्यामध्ये काहीच फेज डिफरन्स नाहीये. दोघंही सिंक्रोनिझम मध्ये आहे. दोघांचंही व्होल्टेज आणि करंट दोघंही एकाच पॉइंट पासून स्टार्ट होतात. इफ I have represented you this concept in the initial lecture of first chapter, then also I will discuss. This is your DC power supply. Okay, this is your DC power supply, and your AC power supply is like this. So here in AC power supply, your power gets divided into 3 types: active, reactive and apparent power, due to the phase angle between voltage and current. But in the case of DC power supply, it is just V into I. It is just V into I, that is product of voltage and current. And these are the 3 equations of power. Okay, so keep in mind this formula. These are the very simple formula. In between analysis, sometimes we may have to use this formula. Okay. So this was the basic concept of power. I hope you must have understood. Now we will discuss our main part of this chapter, that is maximum power transfer theorem. In short, it is also called as MPT theorem. It is also called as MPT theorem. And the statement for this MPT theorem was asked in winter 2007, summer 2009, winter 2014, summer 2016, winter 2010, summer 2011, winter 17, summer 11, winter 13 and winter 17. That means in this question was asked in the MSBTE examination for 8 times with 2 marks. That means this question for the statement purpose, as I told you in initial part of this 5th chapter, statement may ask for the 2 marks. So for 2 marks, only just statement was asked in the examination. In winter 7, summer 9, summer 10, winter 10, summer 11, winter 13, summer 14, winter 14, summer 16, winter 16, winter 17. So in these types, that means sorry, not 8 times, 11 times this question was asked in the examination for 2 marks. So the question was asked in this manner: state maximum power transfer for DC circuit, or state maximum power transfer theorem related to DC circuit, or state maximum power transfer theorem applicable to the DC circuit, or just simply state maximum power transfer theorem. So in this manner, these questions was asked for 11 times in the MSBT examination for 2 marks. That means there is a chance that this question may be asked in MSBT examination this year also. Okay, as I initially told you, there is a pattern. If superposition theorem is asked in the examination, then there will be numerical on Thevenin's. If Thevenin's is asked, Thevenin's theorem is asked in the examination statement, then numerical and superposition will occur. Similarly, if maximum power transfer theorem is asked, then numerical and Norton's theorem will be there. And if Norton's theorem statement is asked, then there will be numerical and maximum power transfer theorem. So that's why we have to study this maximum power transfer theorem also. So the first paragraph, this paragraph is nothing but your statement for the maximum power transfer. This is your statement for the maximum power transfer theorem. So what is the statement? The maximum power transfer states that maximum amount of power will be delivered to the load resistance when the load resistance is equal to the Thevenin's or Norton's resistance of the network supplying the power. What this theorem states? Theorem काय सांगतो? This theorem states that the maximum power will be delivered to the load resistance when the value of load resistance is equal to the either Thevenin's resistance or the Norton's resistance of the given network which is supplying the power. For example, a circuit is given to you and it has been stated that please calculate the power, maximum power. So how to calculate that? To calculate that, we have to use the same procedure as like Thevenin's theorem here. Thevenin's theorem मध्ये जी काही प्रोसिजर आपण यूज केलेली आहे, सेम प्रोसिजर इथे आपल्याला वापरायची आहे. ओके, सो आफ्टर कॅल्क्युलेटिंग open circuit voltage and Thevenin's resistance, we can calculate the maximum power transfer. So by which formula we can calculate the maximum power transfer, we will discuss after this point. But how to identify that how much power is going to deliver to the load? See here is the statement: if a load resistance is lower or higher than Thevenin's or Norton's resistance of the source network, then power delivered to the load is less than maximum. Maximum power transfer कधी होणार आहे? म्हणजे मॅक्सिमम पॉवर ट्रान्सफरची कंडिशन काय सांगितलेली आहे? जर समजा तुमचा RL is equals to RTH असेल, that is if load resistance is equal with the Thevenin's resistance, then and only then maximum power transfer is possible. If not, if the value of your load resistance is either lower than Thevenin's resistance or higher than the Thevenin's resistance, then the power delivered to the load is less than maximum. म्हणजे याचा अर्थ काय? जर RL is equals to RTH जर असेल, म्हणजे लोड रेजिस्टन्सची व्हॅल्यू थेव्हनिन्स रेजिस्टन्सच्या इक्वलच असायला पाहिजे, अशा कंडिशन मध्येच मॅक्सिमम पॉवर ट्रान्सफर होईल. जर लोड रेजिस्टन्सची व्हॅल्यू थेव्हनिन्स पेक्षा कमी किंवा थेव्हनिन्स पेक्षा जास्त असेल तर अशा केसमध्ये लोडला जो पॉवर ट्रान्सफर होतो आहे त्याची व्हॅल्यू ही कमी असते. मॅक्सिमम व्हॅल्यू जी काही ती अटेन करणार आहे त्याच्यापेक्षा कमी आपल्याला पॉवर लोड रेझिस्टन्स साइडला मिळते. दॅट मीन्स दिस इज अ कंडिशन. यू कॅन क्रॉस चेक युअर आन्सर. इफ your load resistance is less than Thevenin's resistance, then of course your maximum power will be having less value. The maximum power will having less value. So what is that concept? When we will discuss the numerical on this part, you will understand it. Okay. So there is a condition for maximum power transfer. That means there is a formula that how to calculate the maximum power when RL is equals to RTH is given to you. ज्यावेळेस RL is equals to RTH असेल त्यावेळेस मॅक्सिमम पॉवर कशी कॅल्क्युलेट करायची त्याचा एक फॉर्म्युला तुम्हाला दिलेला आहे. ओके, वी हॅव टू डिराइव्ह दॅट फॉर्म्युला अँड फॉर दिस there is a derivation and this derivation was asked in the winter 2017 examination for 4 marks. This theorem was this condition for maximum power transfer theorem was asked only one time for 4 marks in winter 2017 examination. That means this question may come in your summer examination. Sorry, not summer examination, winter examination. Winter examination मध्ये म्हणजे आता जी तुमची एक्झाम होती फ्रॉम फेब्रुवारी टू मार्च त्या एक्झामिनेशन मध्ये हा चॅप्टर वरती हा क्वेश्चन कंडिशन फॉर मॅक्सिमम पॉवर ट्रान्सफर सुद्धा येऊ शकतो. ओके, सो वी विल अंडरस्टँड हाऊ द फॉर्म्युला फॉर मॅक्सिमम पॉवर ट्रान्सफर थिअरम इज डिराइव्ड. सो हियर अ सर्किट इज शोन टू यू विच describe the Thevenin's equivalent circuit. If you see, this is your Thevenin's equivalent circuit. Remember Thevenin's theorem. In step 3, we have drawn this type of circuit where we have calculated the VOC, open circuit voltage, we have calculated the RTH, and this is your load resistance through which we have to calculate the current. Okay, so this is your Thevenin's equivalent circuit, and the load power formula is PL is equals to IL square RL. IL square RL according to formula for power P is equals to I square R चा जो formula है P is equals to I square formula. If you rearranged, if you put some additional variables or you change the nomenclature for that power formula according to the value of this load resistance, then your formula becomes PL is equals to IL square RL. Now we know according to statement, if your load resistance is equals to Thevenin's resistance, then maximum power transfer is possible. Hence RL is equals to RTH. This condition we have to follow during maximum power transfer. RL is equals to RTH. So in this condition, what will be the formula for this PL? Of course, IL square RL will be there. But if IL square value is not given to you, then how to calculate the maximum power? So by using this condition of RL is equals to RTH, we will now derive the formula. So here a proof is given to. That means how to. This is the condition RL is equals to RTH, and how this RL is equals to RTH condition is derived. He condition kashi derived झाली we are going to see here. So while writing this answer to the question of condition of maximum power transfer theorem, initial part we have to draw this circuit diagram and we have to write down that then the condition for maximum transfer of power to the load is RL is equals to RTH, and then in next line writing the heading as a proof we have to derive this condition. So this is the proof. So to obtain the condition for maximum power transfer, refer the circuit. This circuit we have to refer here. It is the Thevenin's equivalent circuit for a complex network. We have reduced a complex network into Thevenin's theorem by using that circuit. Okay. So here RL is nothing but the load resistance that represent the load. Load resistance है RL म्हणजे, and that load can be your heater, bulb or motor in practice. लोड रेजिस्टन्स येतो आणि लोड रेजिस्टन्स काय असू शकतो, तुमचा इलेक्ट्रिक हिटर असू शकतो, तुमचा बल्ब असू शकतं, किंवा तुमची मोटर असू शकते. सो रेफरिंग टू दिस गिवन फिगर Thevenin's current can be calculated as IL is equals to VOC divided by RTH plus RL. Remember Thevenin's theorem. In Thevenin's theorem we have calculated the load current. IL is equals to VOC divided by RTH plus RL. Okay. So power delivered by the load, P is equals to IL square RL. This is your formula. Okay. P is equals to IL square RL. Put the value of IL here. VOC divided by RTH plus RL whole square into RL. Okay. इथपर्यंत आलं. Next, the next step is the power will be maximum if the derivative of the power with respect to load resistance is 0. When we will say the power will be maximum, if we have taken the derivative of this power with load resistance RL, so derivative of this power dP by dRL is equals to 0. So d by dRL, replace the value of P by this formula, VOC divided by RTH plus RL whole square into RL. So this will be your value as equals to 0. म्हणजे आपल्याला कंडिशन फाइंड आउट करायची RL is equals to RTH, त्याच्यासाठी म्हणून ही अरेंजमेंट आहे. फॉर दिस वी आर गोइंग टू सी दिस अरेंजमेंट. Okay, so now solve this derivation. You just write down in your notebook. It may confuse you that how this derivation is solved if I try to explain you. So just you write down the format for derivation. We have derived this equation, and after derivation we are getting this arrangement: RTH plus RL square into VOC square into 1 minus VOC square into RL plus 2 into RTH plus RL divided by RTH plus RL raised to 4. Okay. Now solve this equation. Okay, how to solve? Now move this division pointer to the right hand side. हा जो खालचा डिव्हिजन मधला आहे तो राइट हँड साइडला शिफ्ट करा. 0 इंटू RTH प्लस RL रेज टू 4 इज 0. आणि मग हे सॉल्व करा. RTH प्लस RL होल स्क्वेअर, दॅट इज A plus B whole square formula. So A square plus twice AB plus B square. So RTH square plus 2 RTH RL plus RL square into VOC square into 1 is VOC square minus whole this term is into multiplication. So 2 VOC square RL into RTH plus RL is equals to 0. Multiply this VOC square with this term and then rearrange the given term. Okay. हे मल्टिप्लिकेशन केलं. VOC स्क्वेअर RTH स्क्वेअर इंटू VOC स्क्वेअर प्लस 2 RTH RL इंटू VOC स्क्वेअर प्लस RL स्क्वेअर इंटू VOC स्क्वेअर माइनस 2 VOC स्क्वेअर RL RTH minus of 2 VOC square RL square. Now see here, 2 RTH RL VOC square, this is your one term, and this is minus 2 VOC square RL RTH, these two terms will get cancelled. These two terms will get cancelled. So what is remaining? RTH square VOC square minus 2 VOC square RL square plus RL square VOC square, minus 2 plus 1 minus 1, so minus RL VOC square is equals to 0. Shift this RL VOC square term to the right hand side, you will get this value. RTH square VOC square is equals to RL square VOC square. Here VOC square get cancelled, and taking the square root of this RTH square is equals to RL square on both the side, you will get the condition as RTH is equals to RL, and this is the condition for maximum power transfer. Okay, this is the condition for maximum power transfer. I hope you must have understood the derivation. In next lecture we will discuss that how to calculate the maximum power using the formula, and what are the stepwise procedure and application for maximum power transfer. Till then we will stop here. Thank you.